In this video, I'll show how to do exercise 429 over here to the right of the screen. We'll first do it in 2D and then we'll extrude the three bearings or bosses, whatever. Oh, okay, forgot this one, but we'll extrude these to some value, extrude the webbing or the flanges to another value, and extrude the webs to a small value. I don't know that my handout uh, has them. This is out of the introductory handout, but the 3D handout, 3D class should have extrusions to extrude all the three different elevations or extrusion heights. We'll start with, by the way, notice these are the identicals. So just draw one and copy it over. Let's see, typically the web here is 0.3. This is a perpendicular from the circumference of this bearing to the offset arc here. And let's see here. I got dynamic input turned on. I got polar tracking set to 90 with no additional angles. Once you learn object snap tracking, I don't think you'll ever turn it off. And for the object snaps, instead of the default 4 that AutoCAD comes out of the box with, I got these 5. Several instructors use these same ones. So as time permits, you might add insertion, node, the tangent, perpendicular you want to keep, and nearest you want to keep for OSNAP override only. In perpendicular, tangent, and nearest use only as an OSNAP override. They'll cause trouble if you have them running. All right, we're on layer 0. Okay, I'm in the 3D modeling workspace. Come down here to the workspace switching and change it to drafting and annotation. Though nearly everything you use on drafting and annotation is also on 3D modeling, but I kind of missed the layers and the properties, I believe. At least properties is hard to find on 3D modeling. Let's start with let's start with a circle. These are done with diameters. So we'll do circle center diameter, pick a random point. The big circle at the top and bottom left of the exercise are 2.8. So when asked for diameter, we'll type 2.8 and hit enter. I'll hit circle center diameter, hover over the circumference, snap in the middle, and the middle one is 1.4. Exactly half of that. Now we'll copy this pair of circles straight down 4.7. Enter. And let's see, these are 2.2 and 0.8 over here. Let's draw a guideline to put them, start them. Let's see, that is 6 units to the right. I'll place it here and then move it straight down 1.4. Circle center diameter, snap at that end point, 2.2. Enter, click circle center diameter again. Don't just hit enter. Snap, and the small circle is a measly little 0.8. Enter. We'll move these down. Select them both with a crossing window and slide them straight down 1.4. Enter. Now this line is simple, quadrant to quadrant. Just go line, snap at the 9 o'clock quadrant, come down, snap at the 9 o'clock quadrant, enter. This one's more difficult, tangent to tangent. Well, tangent should never be running because it clashes with both center and quadrant. So if it's running, it should be the only one running. I think it's quick enough just to use snap overrides. Click line, hold shift right click, pick tangent, snap where you expect the tangent to occur. Click. It's only good for one snap. for 1 point. So do it, repeat it again for the second point of this tangent to tangent line. Hold shift, right click, pick tangent. You can always type TAN, first 3 letters of an O snap if you're quick with a keyboard. There you go. Can't think of a use for this line. Let's lose it. Let's see, let's draw a fillet here. That arc over here is using screen capture snip, I think. Hope that dot shows up. Excuse me. This is a concave arc of a radius of 5.7. So let's take advantage of the fillet, set the radius to 5.7, and click to place the concave arc. Now, typically, the offset of these lines and arcs here are 0.3. So let's launch offset. Offset begins, set the offset distance. Quite different from fillet. I don't know why. 0.3, enter. Offset that guy inward, offset that guy inward, offset that guy in, out, in, out, in, out, inward. Okay, now let's draw a perpendicular line there. Perpendicular is an O-snap override. Dangerous to keep it running. Click line, I'll shift right click on perpendicular, and then shift right click perpendicular to the nearest arc there. Okay, this is a 0.3 typical. Enter, escape to finish. 0.3 offset. We want to go half of that each way. Well, half of 0.3 is 0.15. So it's offset, set the distance to 0.15, enter. Offset it that way and offset it that way. Before we forget and get careless, let's delete that. Yeah, I want to delete this, trim this out so that when we fill it, with the trim set as with default settings, it'll truncate the arc. So let's trim this out so it won't truncate. You know, we can put an arc in each spot and without losing the big arc. What are these? R.2 typical here. Okay, fillet, we'll go to radius 0.2. I'm sorry, we forgot to trim, enter to be sure everything's a cutting edge. Late 22 and I believe 24 are everything's a cutting edge by default, but I'm still transitioning from early 22. So I'll click there, and what happened? Always something will U enter undo. Try that again. Enter or trim, enter, click. Well, not sure why that happened. Let's try that again. I wonder if, okay, it's a slight gap there. Let's regen, R-E-G-E-N. Interesting. No idea why they didn't touch. Let's use the extend option. Drop down with trim. Enter so everything's a boundary, and click these so they go far enough. Wonder if that had something to do with the regen. Anyway, fixed it with extend. Hit escape or enter to finish extend. Let's go to fillet. Fillet, we already set the 0.2, so let's click, and it truncated. Did I forget to trim that? All right, trim. Well, with the same flyout as extend, enter, erase it. Enter to finish, trim, click. Okay, seems to be working now. Click. Let's fill it here. Since this is a full circle, nothing will be truncated from the circle. Enter to invoke the last used command. Click, enter to invoke the last click, enter, click, enter, click, click, enter, click, click, enter, click, click. And I see I need to trim those guys. Been wise to trim it earlier, but that's okay. Trim, enter, so everything's a cutting edge. Delete those. And we'll fillet these guys again. But fillet, check the radius, still 0.2, click, click, enter, click, click. Now we could use, for center marks, we could use I've been teaching lately this new center mark icon, but it'll likely be on the current, layer, it'll be a center to line type, it'll be, what else? Anyway, there's lots of adjustments to make when you do center lines. There's two or three, I think three type in system variables where you can control the layer it's on, the line type it comes in on, which I recommend continuous. And then you still need to adjust the whiskers so it's proportionate to the size of the circle diameter you place them on. Although professionals probably don't take the time to do that. Anyway, we'll skip the center marks and dimensions, just stick with layer 0 for now. Next is to swell it up. Let's see, how about 0.2, 0.4, and 0.6. Okay, let's toggle over to the 3D modeling to get to the extrude and press pull icons. I'm liking this press pull more and more. Let's try that. Press pull, select between the circles here. It detects the void. Click. And that would be 0.6. Enter. Click again. Extrusion 0.6. Enter. And those are the big objects. So leave it as it is. Hit enter to finish. Enter to press pull. Click between the objects. Now hope this will work. You got to have perfectly closed ends. So let's see if I drew it perfectly. Click. Extrusion height would be 0.4. Medium size extrusions. And we'll click there. Extrusion would be 0.2, enter. Click there, 0.2, enter. Well, let's see if it worked. We'll come over here to 3D free orbit. I don't like the orbit icon. I wish it wasn't the first one on the flyout. It's very limited. Free orbit's well worth the time to learn. Click it. Here's the gerbil ball. Let's rotate it. I believe we are successful. However, the bottom of the object is flat. I'll show you that with a spray painting or a visual style. Yeah, we see it's flat. Most of my hand, whoa, what happened there? All right, we'll fix that. Let's go to top view. Anytime you use an orthographic view, double check the UCS didn't change on you. There's a couple, was it UCS ortho and UCS follow, I believe, or system variables. By default, the UCS change on you when you least expect it. Let's go to 2D wireframe. Good, there's the square, so we're still in the world coordinate system. Let's go to press pull. And all right, Y, hit escape. Okay, not sure what, okay, where's my cursor? Press pull, slide over, type a command. Okay, I'll hit escape. Interesting, not sure why hitting escape got me back into press pull, but that's okay. Hit escape. Enter for the last use command. Click. I think I detected everything. Press pull extrusion height. This is the least of the three heights, so 0.2, enter. Enter to finish. Let's go to conceptual or X-ray. Do X-ray. 3D free orbit. Okay, I think we're looking good now. Now the hard part, centering everything. So it's symmetric about the center line. The web is recessed equally on the top and on the bottom. Remember, right now it's totally flat on the bottom. This is helpful. Well, if we draw some guidelines, sometimes quadrant O snaps work. Endpoints aren't quite as prevalent as you'd like on cylinders. How about we move the 0.2 and the 0.4 stuff up a 0.1 unit. And then we'll move the webs up 0.1 unit. With O snaps, you don't have to do the arithmetic, but since we use 0.2, 0.4, 0.6 extrusion heights, let's take advantage of the easy math. Let's go to move. I'll select, I believe I need to select that guy yet. Enter. This is where I like the learning absolute coordinates. The movement vector is to be 0.1, right? So begin the movement vector starting at 0, 0, 0, enter. And the second point will be just 0.1 straight up to center the 0.4 extrusions. 0, 0, 0.1. Watch it. And what happened? Take a look. All right, something weird happened. Looks like that only extruded 0.2. Did I mistype? Probably. Okay, let's move previously selected stuff, enter, and move it from that point, type, instead of, I forgot to type 0, 0, 0, so I'll type at 0, 0, 0.1. I think I over selected, didn't I? Let's see. I think I got need to move the two webs up 0.1 unit. I gotta fix this guy over here. Let's move two small webs, enter 0, 0, 0, and move it to 0, 0, 0.1. So it moves 0.1 units straight up. Now then, how do we fix this? It is 0.2. We want it 0.4. I think if we copy it on itself, we can make it the right extrusion amount. Let's change the visual style to get a better. Yeah, looks like the thin webs are the right. Carelessly move this guy a hair up. Tell you what, let's second thought, I think I'm gonna have to move lots of stuff down. I think I messed up. Probably should make the video again, but too lazy, so we'll move everything from 0, 0, 0 to 0, 0, minus 0.1, enter. And how does this look? Okay, disregard the remnant lines. Sometimes a few lines, sometimes all the lines get left behind. We can move everything that's solid straight out. And I'm going to copy this guy 0.1 up and 0.1 down. Okay, let's copy, select this flange, enter. We'll go from here to this midpoint. That's exactly 0.1 because it's 0.2 thick. And enter, enter. We'll copy this bottom one, replicate it from endpoint to midpoint down. Good housekeeping. Let's union these three together. Let's move everything that's a solid. We could use quick select, but simply picking them is easy enough. 1, 2, 3, 4, 5, 6. I think that's all the solids. Let's move it in the Y direction. A nice round number in case I forget and need to move it all back. Where's the polar? There it is. Make it a nice round 10 unit move. Enter. 3D free orbit. I believe we are finished. You might want to union it all together if you want a quick and easy way to find the volume, which will lead you to the weight, knowing the density. And for good housekeeping, I'll erase all of this. Whoops, I lassoed the wrong way there. Put it in the top view, and we'll return to 2D wireframe to ensure we haven't gotten off the world a user coordinate system. That's it. Catch you later. Bye.